Okay, here's an example problem. Let m and be integers. Compute negative pi to pi of sine mx sine nx. Think about that question. So, we use the product to sum formula because it's a product of two sines. We can rewrite it as a sum of cosines, right? The formula is negative 1/2 cosine mx plus nx minus cosine mx minus nx. That's why we will need to calculate. And then you can pull the negative 1/2 out. And we can factor the x's out, and you get cosine m plus nx minus cosine m minus n x. And although this looks very complicated, just remember that m and n are some numbers. So just think about m plus n as something like a. What's the integral of cosine ax? If this was some number a, what's the integral of cosine ax? 1 over a times sine ax, right? Here a is just m plus n, so you can use that. 1 over m plus n sine m plus n x. And then same thing here, minus 1 over m minus n sine m minus n x. And you're plugging in what and what? Pi and negative. Okay. Now you might wonder where we use the property that m and n are integers. This is the place where we use it. See, if you look at the sine graph, sine is like, here's 2 pi, pi, and it goes from 0, it goes up, 0, down. That's one period, but it's a periodic function, right? So this thing should extend left and right. And because it's 0 at 0, pi, and 2 pi, the next stop when it hits 0 is 3 pi. And on this left side, it would be negative pi, negative 2 pi. So next stop when it hits 0 is negative 3 pi. So if you look at the graph of the sine, you can see that all the x-intercepts are at where? Some integer multiple of pi. So when you plug in pi here and you get some integer, see, if you add two integers, it's an integer. Some integer times pi. What's the value? If you plug in pi, see, we still haven't evaluated this. We have to plug this in and subtract, right? So if we plug in pi in here and it's integer times pi, what sign of integer times pi?
0.
It's 0. We just figured out that at integer multiples of pi, sine is 0, right? What about this one? Integer minus integer is?
Integer.
Another integer, integer times x, and integer times, when you plug in pi,
0.
it'll be 0, right? What would happen if you plug in negative pi?
0.
0 again, because if you plugged in negative pi here, negative times some integer is another integer, right? So, what's the conclusion?
0.
It'll be 0. Okay. So, with all this work, and we got 0. However, there is one thing that we didn't do carefully. and I doubt anyone here would know what's the problem with this calculation. Anybody? Probably not. Okay. So let me point out that there is something wrong with this calculation, because if m is equal to n, then what would happen?
Undefined.
This fraction will be undefined, right? So this calculation is only valid when? Assuming m is not equal to n. But what if m is equal to n? What happens then? If m is equal to n, then this is still valid, right? From here to there, there's this equal to this equal to this. There's nothing wrong with this, right? Well, what happens here when m is equal to n? What do you get? Come on, if m and n are equal, what do you get here?
Oh, 0.
0. What's cosine 0?
1.
That's what you get, right? Okay. And again, the integral of this is 1 over m plus n sine m plus n x. And then integral of minus 1 is minus x. Negative 1/2 is still there. And you have to plug in pi and negative pi. Again, when you plug in pi or negative pi to sine, you get 0. But here, you get something else. If you plug in pi, you get negative pi. If you plug in negative pi, you get pi. So if you subtract those two, you get negative 2 pi, but times negative 1/2, you get positive pi. Okay. So the result of this question is actually pretty complicated. If m is equal to n, the answer is pi. If m is not equal to n, the answer is
0.
0. So that's the result.